Hello, my dear students. Welcome to BYJU'S Exam Prep, the most comprehensive preparation app for a GATE and ESE preparation. In this particular daily dose video, I'll be helping you to understand a very interesting concept of radiation heat transfer. So let us hear out what does this question talks about. The number of space and surface resistance when a non-black body shield is introduced between two long parallel plates. So if I draw the diagram, there are two long parallel plates, right? And they are saying these are black plates. So your emissivity for the two plates will be equal to 1. This is plate number 1 and plate number 2, right? And they will be having this emissivity because these two are black plates. In between this, I'm inserting a shield which is a non-black body. In between this, a non-black body shield is introduced. So question is, how many number of surface and how many number of space ratios will be present in this particular arrangement? Now, whenever we are reading this type of question, back of the mind, we are having a direct straight shortcut formulation, that is number of surface resistance is equal to 2n plus 2, right? And number of space resistance is equal to n plus 1. This is the formulation that we are getting back of the mind, where n is definitely number of shields. Number of shield. In this problem, your n is equal to 1 because we are having one shield. This is your shield. And I hope everyone knows shield is basically introduced to reduce the rate of heat exchange between two surfaces. Now, coming back to the question, if you try to apply n equal to 1, you will be getting surface resistance is equal to 4 and space resistance is equal to 2, which is incorrect. The reason being, you can only apply this formulation when all the surfaces are non-black body. So let us understand then what will be the answer for this. If I talk about the surface resistance, now surface resistance basically depends upon the emissivity or the type of surface we are having. Okay, because surface resistance is nothing but 1 minus emissivity upon emissivity into A. If I talk about a black body, its emissivity is equal to 1. That means its surface resistance will be tending to 0, right? If surface resistance equal to 0, that simply means you will be having a 0 surface resistance on both of these surfaces, 0 and 0, right? We will be only having surface resistance only on these shield, that is surface resistance 1 and surface resistance 2. So in total, the number of surface resistance in this particular arrangement will be equal to 2, not 4. Please make sure this, because we are having two black surfaces and we know that black surfaces are always having 0 surface resistance, right? Talking about the space resistance depends upon very one important factor, that is we call it as shape factor. Okay, it depends upon the shape factor, and definitely we know that shape factor depends upon how the surfaces are inclined to each other, or we can say what is the configuration of the surfaces, right? That means, are the surfaces kept parallel or are they kept at incline? Okay, are we having a curved surface or are we having a straight surface? So this is basically depends upon the configuration of the surface. So definitely, if it's a black body or a non-black body, it is independent. You will always having a space resistance in between this. So number of space resistance is coming out to be 2. So in total, we are having 2 surface resistance and 2 space resistance. Your final answer is C and D, not A and D, right? And we know very interestingly that if you are having a 2 surfaces, let us suppose there are surface 1 and this is surface 2, right? And both surfaces are kept at same temperature, T Kelvin. But this is a black body and this is a non-black body. So if we're having E1 emissions from here and E2 emission from the second surface, both kept at same temperature, we can surely say that your emission from surface 1 will be more than that of emission from surface 2. The reason being, because surface 2 is a non-black body, so it will be having a surface resistance which will be decreasing the amount of emissions from that surface. Okay, so I hope so now you have understood the concept of surface resistance, space resistance, and the black body. So combined, if I see these three concepts, we are able to solve this question. So final answer is option C and option D, that is surface and space resistance. Okay, so this is all about today's daily dose from the radiation heat transfer. I hope you all enjoyed this. So please do like this session and please do subscribe to this channel for all such awesome content for all our mechanical, civil and exec aspirants. So this is Sooraj Gopi signing off from your own BYJU'S Exam Prep. Thank you.